Hello everyone, I hope you had a good weekend. Welcome back to Khan Academy. This is week 2 of quarter 4. It's crazy to think that we only have 8 weeks left of school. So we're continuing to do our virtual learning thing. We are still in Unit 8 this week, and this is Unit 8 Part 2. It's a shorter unit, so we're actually going to move on to Unit 9 next week. But finishing up this unit, we are talking about simplifying rational expressions. This week's assignments, what are you responsible for? First of all, you have a 20-question classwork assignment as usual. There are 5 guided notes questions and 15 math questions. And then there are 3 Khan Academy objectives due on Friday night. So it's a 3-point homework assignment in the gradebook. You have simplify rational expressions, add and subtract rational expressions, and multiply and divide rational expressions. Those are the objectives that are due on Khan Academy. All of them are worth 1 point in the gradebook for a total of 3. All right, what did we do last week? So last week we were introduced to rational functions, and those are ratios of 2 polynomials, right? We utilized the simplest form of a rational function called the inverse variation. That was in the form y equals k divided by x. And then we analyzed graphical features of rational functions. We found points of discontinuity, which are called holes and vertical asymptotes, and we differentiated between the two. And then we also found horizontal asymptotes. And now what we're going to do is, instead of looking at the graphs of rational functions, we're just going to look at rational expressions and we're going to simplify them. So this is actually a lot more straightforward than last week's lessons. We are doing math. We're factoring, we're multiplying or dividing or adding or subtracting, we're simplifying, combining like terms, that sort of thing. And it's going to be a little bit more straightforward, the material that we're doing. I'm not going to say it's easy, all right, but it is more straightforward. Another thing that we're going to do is we are going to state restrictions on the domain. If you're wondering what does that mean, trust me, it's a lot easier than it sounds. Requisite skills. If you want to be successful in this lesson, you should be comfortable in 3 things. Factoring is huge in this lesson. You're going to be factoring a lot, probably every single problem for the most part, at least pulling out a GCF of every problem. And if you are not comfortable with that, please be watching videos on Khan Academy about factoring when a equals 1 or when a doesn't equal 1, how to take out a GCF, that sort of thing. Please be watching those videos. So factoring, finding GCFs, and then lastly, we are going to be adding rational functions together, subtracting them, which means that we're adding or subtracting fractions. If we are adding or subtracting fractions, you need common denominators. So finding the least common multiple so that you can do that addition and subtraction with common denominators, that's something you need to be comfortable with as well. These steps you should definitely write down. We are going to follow these for every problem today. Step number 1, if you are given a rational expression and you're asked to simplify it, please make sure that you factor everything at the very start of the problem. If you see a GCF that you can take out, take it out. If you see a quadratic that can be factored, through the AC method, blank times blank equals AC, blank plus blank equals B, that sort of thing, factor it. If you see a difference of squares or a perfect square trinomial, factor it. Got to factor everything, okay? That includes on the top and the bottom of these rational functions. Simplify if possible. What you're going to see, and you saw this already last week when we were finding points of discontinuity, is sometimes you get the same factor on the top as you do on the bottom of the fraction, and then you can just cancel it out. That's what we're focusing on, is canceling out factors that appear on top and bottom. Then you're going to perform the operation. So if you are adding, you add the fractions. If you subtract them, and so on. And then simplify further if possible and write your final answer while also stating the restrictions of the domain. We'll talk more about that in a little bit. Some important notes about specific fractional operations. I'm not going to do just addition and then just subtraction, that sort of thing. I'm going to be talking about all of them at once because you know how to add, subtract, multiply, and divide fractions. That's not new. What's new is this new context. You're seeing more complicated problems with polynomials on top and bottom of the fractions. but I want to go through these things as some friendly reminders. First, when adding or subtracting fractions, which is what you're doing today, even though they're rational functions, they are fractions, right? Rational functions are fractions. When adding or subtracting them, you always need common denominators, always. That is not the case for multiplying or dividing. You can have different denominators, but for adding or subtracting fractions, you need the same denominator. When subtracting polynomials, you need to make sure you use parentheses because you don't want to forget about the second or third term applying that negative sign when you're subtracting. When multiplying fractions, you're multiplying straight across. None of that cross multiplication. That's when you have a rational or a fractional equation, like a fraction equaling a fraction. That's for cross multiplication. But today we're just dealing with expressions and simplifying them. If you got a multiplication symbol, multiply straight across. And then finally, when you are dividing fractions, make sure to utilize keep, change, flip. That's relevant only for division, not for anything else, okay? You keep the first fraction the same, you change the division to multiplication, and then you flip. You flip the last fraction to its reciprocal. And then it's just a multiplication problem, and you do it as normal. What is a domain restriction? You're going to see this in every example today, unless I forget to write it down, but I shouldn't. A domain restriction is any x value that would result in the denominator of 0 for a rational expression. Okay? For instance, if you had an inverse variation like y equals 1 divided by x, x can't be equal to 0 because then you would have 1 divided by 0 and you can't divide by 0. It's impossible to divide by 0, so we need to say that x cannot equal these certain values that would make the denominator 0. These x values are called domain restrictions and are stated at the end of the problem with a not equal to sign. If x can't be equal to 0 because it would set the denominator in the problem at any point equal to 0, at the end of the problem, excuse me, you are going to write x cannot be equal to equal sign with a slash in it. I'll show you what that looks like shortly. 0. So we are going to jump into examples. I have 9 examples for you today, and they are all covering simplifying rational expressions. If you want to jump ahead to a certain part of the video to help you out with, a certain part of your classwork or homework, this is what I'm going to be covering over these next, who knows how long it'll last, I don't know. Numbers 1 through 3 is just simplifying without any operations. So there's no multiplication, division, or addition, subtraction in numbers 1 through 3. They're a little bit simpler. 4 through 6 is when we're multiplying and dividing. And then 7 through 9 is adding and subtracting, which is the toughest case because you have to get common denominators. And with that, I think, yes, I'm going to pull up my iPad real quick here, and we're getting started with our examples. A little bit different this week. That didn't work. Oh, I changed the microphone. My bad. A little bit different this week in that we don't have a ton of objectives to cover. We still have a bunch of examples, but I'm just trying to show you as much as I possibly can here, so that you feel confident moving into the classwork, that sort of thing. All right. Example number 1. In our instructions, I don't have any written instructions here. They are the same for every single problem. Simplify. Simplify this expression as much as possible. Okay. First of all, we have a fraction, a rational expression, 45 over 10x minus 10. Remember that first step is factor everything, right? So I'm going to look at top and bottom here, and I'm going to ask, can I factor it? 45. Can I factor it? The answer is no. It's just a number, right? 10x minus 10. Can I factor it? The answer is yes. It's not a quadratic, it's a linear binomial, but that has a GCF, right? There's 2 terms, and they can both be divided by a common factor. So you have to pull that outside of parentheses, and that's what we're going to do in this first step. The top stays the same. The bottom, we are going to take out a GCF. What goes out into 10x and into negative 10? I hope. You're thinking to yourself right now, just 10, right? Okay, so 10. What goes inside the parentheses? Well, if we divide 10x by 10, we just get x. And if we divide negative 10 by 10, we just get negative 1. Cool. Now that we factor top and bottom, we would usually do the operation like multiplication or division, addition or subtraction, but we're starting off simple without any operations going on, right? So now we ask ourselves, can we simplify this at all? The answer is yes, for sure. Because this 10 and this 45, they're both divisible by 5, right? That's their common factor. So we can simplify the fraction by dividing the top and the bottom by 5. (45) divided by 5, that's 9. 10 divided by 5, that's 2. X minus 1 stays the same here. All right, so can we simplify it anymore? The answer is no. The x minus 1 doesn't cancel out with anything. 9 and 2 don't have any common factors, so this right here is our final answer. But remember that you need to state, for these problems this week, you need to state your domain restriction. This is true for pretty much every single problem on the classwork. And what I said with domain restriction in the PowerPoint is that whatever x value would make the denominator equal to 0, you have to state that x cannot be equal to that value. So what we do is you look at the factors in the denominator of the problem, and honestly it can be anywhere. But this x minus 1 is what's standing out to me here. If we set that equal to 0 and solved, we would get x equals positive 1. You did this last week, right? That means that there is a point of discontinuity at x equals 1. More specifically, it would be a vertical asymptote. What we need for today, though, is not stating that x equals 1. It's stating that x cannot be equal to 1 in this expression. Otherwise, it results in a denominator of 0. So what we're going to say for our final answer is we're going to say 9 over 2 times x minus 1. And then I'm going to put just a little semicolon. And you don't have to worry about this on your classwork because I have a blank for you to fill in the domain restriction. But I'm just going to say x cannot be equal to positive 1 because it results in a denominator of 0 in that fraction. Congratulations, you reached the end of your first problem. Let's move on to example 2, which again is a rational expression without any operation. All right, so we're just looking at one rational expression. Simplify it. Factor the top and factor the bottom. Can I factor this? X squared minus 7x minus 30. The answer is definitely yes. It's a quadratic. I should be asking myself what two numbers multiply to get negative 30 and add to get negative 7. If you don't want the answer right away and you want to work ahead on this at any point among these 9 examples, please just make sure you're pausing the video before you hear me give the answer away, right? You should challenge yourself to work through these on your own before I give you the answer. Anyways, factoring this, two numbers that multiply to get negative 30 and add to get negative 7, that's going to be negative 10, so we have x minus 10, and positive 3, x plus 3. Divided by, okay. Can we factor x squared minus 5x minus 24? Well, it's a quadratic trinomial, so we definitely should try, right? What two numbers multiply to get negative 24 and add to get negative 5? Think about it. We should get negative 8 and positive 3. Cool. Last problem, we had those numbers outside, 45 and 10. We divided both of those by 5. That's not relevant here. But at this point, we should see something that we are able to simplify, right? On the top, we have a factor of x plus 3. On the bottom, we have a factor of x plus 3. What does that mean? It means that we can cancel them out in step number 2. How convenient, right? So we get, as our final simplified version of this polynomial, x minus 10 over x minus 8. This is as far as we can go. That's our final simplified answer. Okay? If you're asking yourself, hey, 10 and 8, aren't those divisible by 2? Well, the answer is yes, but you cannot simplify just the negative 10 and the negative 8 by itself because it has x as a part of that polynomial, right, as a part of that factor. So we can't simplify it any more than that. Now the question is, make sure you're stating your answer in the correct way, right? If this is our simplified answer, what can our domain not be equal to? What are the restrictions on our x value, the restrictions on our domain? Go back throughout your problem and identify any factors on the bottom of your fraction. Any factors on the bottom of your fraction cannot be equal to 0. So for instance, right here, if we had an x value that set that equal to 0, it would not be okay. That x value would be 8. So x cannot be equal to 8. You can see that pretty clearly right here, right? If we plugged in 8, the bottom would be 0. But also, even though we canceled it out, you still have to factor in this factor. X plus 3 cannot be equal to 0. I should include that right here, right? X plus 3 cannot be equal to 0. Subtract 3 from both sides. That means that x cannot be equal to negative 3. So we actually have two restrictions on the domain here. X cannot be equal to positive 8, and it cannot be equal to negative 3. You can just put on your classwork x not equal to 8 comma negative 3. And again, this part here, the x is not equal to, that's already on your classwork, so you don't have to type that. You would just type 8 comma negative 3. And that's your final answer. One more example of just looking at a single rational expression rather than looking at two where there's an operation in between them. We have 6x cubed plus 42x squared divided by 2x squared plus 26x plus 84. Feel free to start this out on your own if you'd like. That was just me taking a drink. Gotta hydrate. Okay, so the top. Can we factor it? The answer is definitely yes. It is a cubic, which we don't see as often as quadratics, but remember that whenever we see two terms, that may be a hint that the main way that we are going to factor this is taking out a GCF. Okay, so that is what we are going to do in this first step. What is the GCF of 6 and 42? The answer is 6. 6 goes into both of them. Well, we also have this x cubed and this x squared, right? So part of the GCF is that variable part too. What is the GCF of x cubed and x squared? It's x squared. We take that outside of parentheses. What goes inside? Well, if we divide those terms by our GCF, 6x squared, we are going to get x. 42 divided by 6 is 7, plus 7, and that's it, x plus 7. If you want to check that, just FOIL it out, or distribute it, and you'll get exactly what we had in the first step. All right, anyways, moving on to the bottom. Can we factor this? 2x squared plus 26x plus 84. The answer is definitely yes, because I see all of those numbers are even, right? So we can first take out a GCF. That's what I'm going to do first. My GCF is 2, because all numbers are even. Dividing each of those terms by 2, I get x squared plus 13x plus 42. Okay. Now, back to my highlighter here. I see a quadratic in parentheses, x squared plus 13x plus 42. Whenever you see a quadratic, you got to ask yourself, can I factor it? And the answer is going to be yes here again. So even though we took out a GCF, that wasn't all that we had to do with the bottom expression. We took out a GCF, and now we actually have to factor this quadratic. Thankfully, our a value is 1. So what two numbers multiply to get 42 and add to get 13? Think about it. I'm going to keep the top the same. All right, so those two numbers, keep the 2 on the outside. Two numbers that multiply to get 42 and add to get 13 will be 7 and 6. Awesome. The reason that I say awesome is because I see an x plus 7 on top and I see an x plus 7 on bottom, which means that I'm going to be able to simplify that, right? If I've got a factor on top that matches a factor on bottom, I can simply say, hey, I'm going to cancel this out. X plus 7 will be gone. What else can we simplify? X plus 6 doesn't appear on top and bottom. However, I do see that 6 and that 2 here. Oh, that wasn't a good color combo. Give me one sec. I think yellow just might work best. 6 and 2, right? Those two coefficients in front, we can say, hey, both of those are divisible by 2, right? So that's what we're going to simplify in this next step. We're going to divide the top by 2. Divide the top by 2. And divide the bottom by 2. So what does this come out to? All right, 6 divided by 2 on top is 3. X squared stays the same. We no longer have x plus 7, it's gone. Divided by. 2 divided by 2 is 1, or it cancels out, right? This cancels out right here. X plus 7 canceled out, and now we are just left with x plus 6 on bottom. That's our final simplified answer. There's nothing else that we can simplify. Please make sure that you state the restrictions on your domain. What can x not be equal to in this problem because it would set the bottom equal to 0? Well, obviously, -6, right? If we plug in -6, that'll make the bottom right here equal to 0. So x cannot be equal to -6. However, don't forget about the factor that you canceled out right here. This x plus 7 can also not be equal to 0 because that would result in that part of the problem having a denominator of 0, which would make the problem impossible. Subtract 7 from both sides and we get x cannot be equal to -7, which is our second restriction on the domain. Our final answer is 3x squared over x plus 6 with a domain restriction of x cannot be equal to -6 and -7. That's our final answer. Great. All right, moving on. If you feel confident with those problems, the rest of them are going to be similar, but now we're throwing in an operation in the middle, right? It could be addition, subtraction, multiplication, or division. So we're going to have two rational expressions with some operation in between. The first step is always the same, though. You're going to factor it. You're going to factor the top and the bottom of each rational expression, if possible. All right. Example number 4, we got a division problem. What does this mean? It means that you are going to have to utilize keep, change, flip, right? So we'll do that after the factoring step, just because we should factor first in all scenarios. So factoring this problem, starting it off the same way. 1, can we factor it? The answer is no. X minus 4, can we factor it? No. X plus 2, can we factor it? No. However, -x squared plus 9x minus 20, we definitely can factor that. So that's what we're going to do. 1 is staying the same. X minus 4 is staying the same. Divided by x plus 2 is staying the same. Over, okay, -x squared plus 9x minus 20. I see a -1 for my a value, which means that I'm going to factor out a GCF of -1. if you're wondering why, when we talked about factoring quadratics back in quarter 2, we said that if your a value was ever -1, you should take it outside of parentheses to start off. Okay, so I'm going to take out a -1 here. What's left inside? The same thing, except each sign switches, right? Because if you divide each thing by -1, it just simply changes the sign. So we will have positive x squared minus 9x plus 20. Now we have an a value of 1 inside these parentheses, and we simply ask ourselves, what two numbers multiply to get 20 and add to get -9? Those numbers will be -5 and -4. So that's my factored quadratic here, which I'm going to put right up here. -1 times x minus 5 times x minus 4. Now, at this point, can we simplify anything? I don't see anything that can be simplified here on that right fraction that we factored. So we're going to perform our operation, which in this example is division. How do I do division of fractions? I do keep, change, flip, as we talked about before. That means I keep the first fraction the same, 1 over x minus 4. I change that division to multiplication. And the second fraction, I flip it to its reciprocal. Now, the -1 times x minus 5 times x minus 4 is on top, and the x plus 2 is on bottom. Now can we simplify anything? The answer is yes, because we're going to be multiplying straight across. That means that x minus 4 appears on top and x minus 4 appears on bottom. This is going to cancel out. How nice. X minus 4, it's gone. X minus 4, it's gone. So now we just multiply straight across, which thankfully we don't have anything on the left that's multiplying except 1, right? 1 times anything is just itself, it doesn't change. So our final answer is going to be actually what we have right over here. We're going to have -1 times x minus 5 over x plus 2. That's my final answer. What is my domain restriction? Okay, with division problems, you have to be extra careful because it's not just that x cannot be equal, it's not just that your denominator can't be equal to 0 at the end of your problem. Your denominator can't be equal to 0 at any point in the problem. Okay, so we're going to work backwards here. And I'm going to highlight each factor where I'm getting a specific number for my domain restriction from. I'm going to do this in green. First of all, your final answer has x plus 2 on the bottom. That means that x cannot be equal to -2. Okay, moving upwards. We had x minus 4 right here. X minus 4 cannot be equal to 0 because it was on the bottom of a fraction. So that means that x cannot be equal to +4. Moving up from there, x minus 4 again, x minus 4 again right here can't be equal to 0, but we already looked at x minus 4. What about this one, x minus 5? That can't be equal to 0, which means that x cannot be equal to +5. And that's it. Our final answer is -1 times x minus 5 over x plus 2, where x cannot be equal to -2, 4, or 5. Example 5. 9x squared plus 18x times, 9x squared plus 18x over x plus 2 times 1 over x minus 2. can I factor the top of the first fraction? Yes, I can. It's a quadratic. It's two terms. I can take out a GCF, so that's what I'm going to do right now. What is the GCF of 9 and 18? It's 9. What is the GCF of x squared and x? It's just x. What goes on the inside? Well, 9x times x will give us 9x squared. And 9x times 2 would give us the 18x. So on top of that first fraction we have 9x over x plus 2. X plus 2 on bottom. Can we factor it? The answer is no. Okay, second fraction. Hopefully you see something in that first fraction, right? On top we have 1 that can't be factored. On the bottom we have x minus 2 that cannot be factored. So now we simplify, and because I see a factor on top and on bottom, we can cancel those out, right? So I see here x plus 2 and x plus 2. That means that I am going to get rid of those because x plus 2 over x plus 2 is 1. So I multiply straight across whatever I have. On top, I have 9x times 1. It's 9x. On bottom, all that is left is x minus 2. Can I simplify anything else? The answer is no, right? I have 9x times x minus 2. Please make sure you state your domain restriction. What can x not be equal to? I'm going to highlight these in green again so that we can examine each one. With this factor, x cannot be equal to positive 2. Same thing with this factor. X cannot be equal to positive 2. But we also had earlier on an x plus 2 in the denominator, actually over here as well. So that means that x cannot be equal to negative 2 either. Our final answer is 9x over x minus 2, where x cannot be equal to 2 or negative 2. Keep up the good work, y'all. You're doing great. We've got 4 more problems left to go. 1 more division, and then we're going to get to addition and subtraction. All right? This is a doozy of a problem because you can possibly factor everything here. All right? If you need to see a more detailed walkthrough about how I factor these problems, then make sure you're asking me on Teams throughout the week, right? But I'm going to factor the top and the bottom of, I think, everything here, actually. So let's do it. On the top of the first fraction, we have x squared minus 9. This is called a difference of perfect squares. You need to know how to factor something like this. If you don't know how, please make sure that you're looking back in your notes or you're watching videos on Khan Academy. You can just Google difference of perfect squares. X squared minus 9 factors into x plus 3 times x minus 3. On the bottom, we have 2x squared minus x minus 10. Unfortunately, this is a problem where you have an a value that is not equal to 1. So this is the hardest type of problem to factor. I'm going to do it off to the side here in a different color, in purple. So this right here is what I'm working on factoring right now. 2x squared minus x minus 10. We need 2 numbers that multiply to get AC, which is negative 20. 2 times negative 10. And we need 2 numbers that add to get B, which is negative 1. Those 2 numbers will be negative 5 and positive 4. But remember, in our next step, we can't just write x minus 5 times x plus 4 because our a value is not 1. So we have to split up the middle term. 2x squared minus x minus 10 is going to become 2x squared minus 5x plus 4x minus 10. Then finally, I take out a GCF from the first two terms and the last two terms. 2x squared minus 5x, the GCF is just x, and I'm left with 2x minus 5. In my second two terms, 4x and negative 10, my GCF is 2, and I'm left with 2x minus 5. Did I do this correctly? Yes, because this and this matches inside the parentheses, and your final factored form, finally got there, is 2x minus 5 times x plus 2. That is what is going to go on the bottom of this fraction, this first fraction. 2x minus 5 times x plus 2. Divided by. All right, so second fraction. Thankfully, this quadratic has an a value of 1. So we just ask ourselves what two numbers multiply to get negative 21 and add to get positive 4. Think about it a little bit. 7 and 3, right? So we have a positive 7 and a negative 3. X plus 7 times x minus 3, should be a parenthesis there, over, finally on bottom here, 4x squared minus 25. When you see the 4 and the 25, you should recognize those as perfect squares. And you have a subtraction sign in the middle, so this is a difference of perfect squares again. This will come out to 2x plus 5 times 2x minus 5 when you factor it. I know that was a lot, right? You're not going to have too many problems where you are asked to factor everything, like literally the top and bottom of each fraction will be factorable. There's not going to be too many problems like that, but they will pop up every once in a while. Anyways, what operation do we have? We have division, which means that you need to utilize, absolutely need to utilize, keep, change, flip. Make sure you do it. So the first fraction we keep the same. X plus 3 times x minus 3 over 2x minus 5 times x plus 2. We change the division to a multiplication, and we flip the second fraction. 2x plus 5 times 2x minus 5 is now on top of this fraction, and on bottom we now have x plus 7 times x minus 3. What cancels out in this multiplication problem? Okay, first thing I see is x minus 3. X minus 3 appears here, and it appears here, so we're going to cancel it out. It's gone. Let's see here. Next thing that I see is 2x minus 5. Appears on top here, and it appears on bottom here, so we're going to cancel it out. Anything else? The answer is no. So we are simply going to multiply these across now. And thankfully, you don't have to write this in standard form. When you're multiplying these together, you can just write one factor after the other. So on the top, you have x plus 3 times 2x plus 5. You can just write that as x plus 3 times 2x plus 5. That's it. And then on bottom, you have x plus 2 times x plus 7. Right here. X plus 2 times x plus 7 is x plus 2 times x plus 7. Nothing else cancels out, so this is your final answer. What is your domain restriction? There's going to be a lot of them, because at any point, a factor cannot be equal to 0 at the bottom. Here are all the values of x that it cannot be equal to. All right. First of all, x plus 2 equals 0. Or sorry, I should say x plus 2 cannot be equal to 0. So that means x cannot be equal to negative 2. X plus 7 can't be equal to 0 because it's on the bottom. That means that x cannot be equal to negative 7. Moving up to the next step, the previous step. 2x minus 5 can't be equal to 0. That means that x, if we set that equal to 0 and solve, cannot be equal to 5/2. X plus 2, we already covered it. X plus 7, we already covered it. Not the x minus 3, though. X minus 3 can't be equal to 0, so x cannot be equal to positive 3. Moving upwards one more time. 2x minus 5 we already covered. X plus 2 we already covered. 2x plus 5, though, we didn't. Right here. We got 2x minus 5, but we didn't get 2x plus 5. At this point, this right here, this factor that I just highlighted, that can't be equal to 0 either, because it would screw the problem up and you couldn't continue. That means that if we set that equal to 0 and solve, x cannot be equal to negative 5/2. So those are all the restrictions on our domain. Yes, it is a mouthful, all right, but it's your full, complete answer. X plus 3 times 2x plus 5 divided by x plus 2 times x plus 7, with restrictions on the domain of x cannot be equal to negative 2, negative 7, plus or minus 5/2, and 3. Ooh, that was a lot. Moving forward to our addition and subtraction problems. Please remember that with addition and subtraction problems, I already went over this in the PowerPoint, but you got to make sure you remember that if you want to add or subtract fractions, you absolutely need common denominators. It's not going to work if the bottoms aren't the same. So with this problem here, we have 2x plus 7 over x squared minus 2x minus 3 minus 3x minus 2 over x squared plus 6x plus 5. There's a lot going on here, right? Excuse me. What are we going to do? First of all, factor everything. All right? If it's getting old, I'm sorry, but you got to do it for every problem. 2x plus 7 can't be factored. X squared minus 2x minus 3 definitely can. What two numbers multiply to get negative 3 and add to get negative 2? It would be negative 3 and positive 1. All right, let's see here. So now we have subtract. Can we factor 3x minus 2? The answer is no. And then let's see here, x squared plus 6x plus 5. Can we factor that? The answer is yes. Sorry. The answer is definitely yes. X squared plus 6x plus 5 factors into x plus 5 times x plus 1. All right, now comes the tricky part. We have to find common denominators, right? However, with a problem like this, rather than like a normal fractional subtraction problem or addition problem, this is actually easier to find the common denominator, okay? Because all we need to do is multiply by something on the top and the bottom of both fractions to get them to match. How can we get the bottoms? X minus 3 times x plus 1 being 1, and the other being x plus 5 times x plus 1 be the bottom of the other. How can we get those to match? How can we get them to be common denominators? Well, the answer is just multiply by what's missing from the other fraction, okay? So what I mean by this is that we are going to multiply the first fraction by this, x plus 5, because it doesn't appear on the bottom. And I'm going to need some more room, so I'm going to do this in the next step here. 2x plus 7, remember what we're doing, we're multiplying by x plus 5 on top and bottom. Minus Okay, what are we going to multiply the second fraction by? We're going to multiply it by what's missing on the bottom. We have x plus 1 and x plus 5, but we don't have x minus 3 on that second fraction. So that's what we're going to multiply by on top and bottom. We're going to have this 3x minus 2 times x minus 3. And then on bottom, we're going to have x plus 5 times x minus 3 times x plus 1. Look at that. Now, if I look at the bottom, this and this match. That means that we have common denominators, right? Now, there's a reason that I saved these problems for last, y'all. It gets very lengthy as far as the amount of work that you have to do, because you need to factor first, then you need to get common denominators. And now, because we're going to be combining the tops, we're going to be subtracting the numerators, keeping the bottom the same. We can't subtract them as they are right now, unfortunately, which means that we're going to actually need to FOIL those problems out. 2x plus 7 times x plus 5, we're going to need to FOIL it out. And 3x minus 2 times x minus 3, we're going to need to FOIL that out. Yes, it is a long process, but you're going to have, that pop up in Algebra 2. So we're going to take care of this. I'm not going to show all the work because you should be comfortable with factoring at this point. FOILing at this point. Again, we only need to FOIL the top, not the bottom. 2x plus 7 times x plus 5 is going to come out to 2x squared, 7x, 10x plus 17x plus 35. On bottom, we still have the same thing. Just going to extend this here. And then we're going to subtract the result of 3x minus 2 times x minus 3. 3x times x is 3x squared. Negative 2 times x is negative 2x. 3x times negative 3 is negative 9x. So we get negative 11x. And then negative 2 times negative 3 is positive 6. All right. And now we're actually going to do this subtraction, right? There's a reason that I wrote parentheses on top. Remember what I said, when you're subtracting polynomials, it's really important that you use parentheses because you need to subtract each term in those parentheses. So what does that top come out to? Well, first thing that we do is 2x squared minus 3x squared, which is going to be negative x squared. Second is 17x minus negative 11x. That's a double negative. I almost missed it, to be honest. 17 plus 11 is 28. We have plus 28x. And then finally, 35 minus 6 is 29. Now, we're not done yet. We actually have to go and factor the top again. This right here, this negative x squared plus 28x plus 29, we have to factor that because possibly we could cancel it out with the bottom. And if it cancels out with the bottom, some factor on the bottom, we have to absolutely cancel it out so we can simplify it more. So I'm going to bring up a new page here. First, I'm going to write this down in my notebook so I don't forget what we have. So again, right now we're at negative, negative x squared plus 28x plus 29 over x plus 5 times x minus 3 times x plus 1. This factors out into, I'm going to do this off to the side here, okay? Negative x squared plus 28x plus 29 has a negative 1 for an a value, so take that out of parentheses first. What two numbers multiply to get negative 29 and add to get negative 28? That would be negative 29 and positive 1. So now that goes on top. That's our factored form of that polynomial. Negative 1 times x minus 29 times x plus 1. And that is divided by x plus 5 times, that's supposed to be a 5, times x minus 3 times x plus 1. And you can see now that we didn't do this for no reason at all. We can see that the factored form has x plus 1 in it, and the denominator has x plus 1 in it, which means that we can cancel those out, and we finally arrive at our answer. We have negative 1 times x minus 29 over x plus 5 times x minus 3. X cannot be equal to negative 5, positive 3, or, right here, negative 1. It's our final answer. Yes, it's a lot of work, right? To sum up here, let me go back to the start of our problem. First thing that we did is we factored everything that we could. Second thing is that we multiplied top and bottom of fractions to get common denominators. Next, when we multiplied, we actually had to do the multiplication and FOILed it out. Combine like terms with the subtraction, and then we actually took this and we factored it again to give us this right here. Final step was simplifying, canceling out terms that appear on top and bottom, and stating the restriction on our domain. Thanks for sticking with me through that one, y'all. Let's keep on going. And I was messing around before, I forgot to erase this. All right, so example number 8, we got 2 more to go. X plus 1 over x squared minus 2x minus 35 plus x plus 6 over x squared plus 7x plus 10. Factor everything first. X plus 1 can't be factored, keep it the same. On bottom, we have x minus 7 times x plus 5. Second fraction, x plus 6 over 2 numbers multiplied to get 10, add to get 7 would be x plus 5 and x plus 2. All right, now both of these denominators have an x plus 5 in common. However, only one of them has an x minus 7, and only one of them has an x plus 2. So the first fraction we're going to have to multiply by x plus 2 on top and bottom. The second fraction we're going to have to multiply by x minus 7 on top and bottom. Again, the reason that we do this is to get common denominators. So I'm going to do that in my next step. The first fraction, I'm multiplying top and bottom by x plus 2. Plus, the second fraction, we are multiplying by x minus 7 on top and bottom. X plus 6 times x plus 7 over x, did we say x plus 7? I meant x minus 7. Sorry about that. On bottom, we now have x minus 7 times x plus 5 times x plus 2. And now we're actually going to combine these together. I'm going to have on the bottom of my fraction the same exact thing because now I have common denominators. We're just adding the tops. Yikes. All right, so let's keep this color coordinated here. The first fraction's numerator is x plus 1 times x plus 2. So if we FOILed that out, that would be x squared plus 3x plus 2. Now in purple, our second fraction has a numerator, second fraction has a numerator of x plus 6 times x minus 7, which means that we are going to have plus x times x is x squared, 6 minus 7 is negative 1, so it would be negative x. 6 times negative 7 is negative 42. So now we are adding these together, right? First, we have x squared plus x squared, which is 2x squared. Next, we have 3x plus negative x, which is positive 2x. Finally, we have 2 plus negative 42, which is negative 40. And on the bottom we have the same exact thing, x minus 7, x plus 5, x plus 2. What are we going to do from this point? Well, on top, we have to factor that and then see if anything cancels out with the bottom. And then we'll arrive at our final answer. So I'm going to write this down in my notebook again and pull up a new page on my app. All right, so final stretch. Factor the top, right? 2x squared plus 2x minus 40 has a GCF of 2. What two numbers? Multiply to get negative 20 and add to get positive 1. That will be positive 5 and negative 4. So this right here is what the top of my fraction factors out to. We have 2 times x plus 5 times x minus 4. Bottom stays the same. Thankfully, something does cancel out here. We can see that x plus 5 appears on top and on bottom, so therefore we are canceling it out. Our final answer, I'm just going to write the same thing except without those x plus 5's. Is 2 times x minus 4 over x minus 7 times x plus 2, and our x values cannot be equal to positive 7, negative 5, or negative 2. Lots of work for sure, lots of work. All right, one more to go. Thankfully this one is a little bit shorter. And then we're done. 4 minus x squared over x squared minus 9 minus x minus 2 over 3 minus x. Here we go. First, when we have 4 minus x squared, that is a difference of squares. However, I'm going to switch this around just a tad, all right? I am going to say instead of 4 minus x squared, I'm going to actually change that to be negative x squared minus 4. Pull out a negative 1 in front just so that it looks a little bit normal with the variable in front, okay? And I'm actually going to do that a second time on the bottom of the second fraction where it says 3 minus x. That's not really a normal way to write that. Usually we would write x minus 3, right? But they're not equivalent. So we need to pull out a negative 1, multiply it by x minus 3. And that's equivalent to what we have in the first step. Or in the original problem, I should say. All right, now we factor everything that we can. On top here, x squared minus 4 comes out to x plus 2 times x minus 2. On bottom, x squared minus 9, difference of squares, again, is x plus 3 times x minus 3. Great. Minus, over here, x minus 2 can't be factored. And we have negative 1 times x minus 3. That cannot be factored either. All right. Now we have a subtraction problem, which means that we need common denominators. Both denominators have a factor of x minus 3. However, the first fraction has x plus 3 and the second doesn't. The second fraction has this negative 1 where the first fraction doesn't, right? So what we're going to do is we are going to multiply the first fraction by negative 1 on top and bottom, and the second fraction by x plus 3 on top and bottom. And then we'll get common denominators here. All right, let's do that. So, there we go. Okay, negative x plus 2 times x minus 2, we're going to multiply top and bottom of that by negative 1. If it looks a little strange right now, that's okay. And then the second, we're going to multiply by, what was that, x plus 3 on top and bottom. So we'll have x minus 2 times x plus 3. Then on bottom, we're going to have negative 1 times x plus 3 times x minus 3. And now we have the same thing on top and bottom. Should be a minus sign. All right, so now we have to subtract the top. This is not going to be as hard as it looks, all right, because we can actually just take out, you see this negative 1 times negative 1 right here? That negative 1 times negative 1 just cancels out to a positive 1. So we can actually cancel that out. So on the top we have x plus 2 times x minus 2 minus x minus 2 times x plus 3. We're going to write this out in a new slide. Give me 1 second. All right, so on top, x plus 2 times x minus 2 is x squared minus 4. And over here, x minus 2 times x plus 3 is x squared plus x minus 6. So that's what I'm going to be writing on this new slide here. We have x squared minus 4 minus x squared plus x minus 6 all over our bottom, which was negative x plus 3 times x minus 3. Simplify the top. X squared minus x squared is 0. It cancels out. Negative 4 minus negative 6 is, in other words, negative 4 plus 6. That'll be positive 2. And then finally we have this positive x right here, but there's a negative sign in front, so we're actually going to have negative x plus 2 over negative x plus 3 times x minus 3. We're going to do one more thing here to cancel out something on the top and bottom, and then we'll be finished. What I'm going to do is on top, because I don't like negative x, I'm going to take out a negative 1 on top, which will leave me with positive x minus 2 in parentheses. And on bottom, I still have negative 1 times x plus 3 times x minus 3. That means on the bottom, and the top, I'm sorry, we have negative 1. Negative 1 over negative 1 cancels out to be positive 1. So I am left with, for my final answer, x minus 2 over x plus 3 times x minus 3. What can my domain not be? What are my domain restrictions? X cannot be equal to negative 3 or positive 3. And that is it. We reached the end of our lecture. Thanks so much for watching, y'all. Let me return to my face here. Cool. Thank you so much for watching. I know it's a lot, especially the addition and the subtraction stuff, trust me. It's a lot for me to talk through all that at once. Anyways, please make sure that on any of these 9 examples, you post any questions that you have about the material or assignments in your class's discussion channel on Teams. Especially with that last problem, because I feel like I didn't present it as well as I could have. If you feel a little bit confused by the addition and subtraction, those are tough problems, so please make sure you reach out to me. Remember that we have live video chats every day, I should say Monday through Thursday at 10:15, 11:45, and 1:45. Typically I do that for my 2A/6B classes, and then my 3A/7B classes, and my 4A/8B classes, but you can join in at any time to ask me questions. And have a great week. I'll see you in Teams. I'll see you virtually. Stay positive and stay healthy. I love you guys. Bye.